Let us now look at a few examples on how the concepts learned above can be used mathematically to solve some problems on mains electricity. Question 1. How many 1000 watt electric iron boxes could be safely connected to a 240 volt main circuit fitted with a 13 amp fuse? Solution. The number of electric iron boxes multiplied by 1000 watts should be equal to the power output, which is current times voltage. So power is equals to the number of iron boxes multiplied by 1000 watts, which is the power of each, and this is equals to current multiplied by voltage. From this, it implies that the number N is equals to voltage times current divided by 1000, which is equals to 240 volts. Current is 13 amps. We divide by 1000. Hence, the number N is equals to 3.12. These are approximately 3 iron boxes. The other question is, an electric heater is made of a wire of resistance 100 ohms and connected to a 240 volts mains supply. Determine the power rating of the heater. So power is equals to VI. From Ohm's law, V is equals to IR, and therefore I is equals to V over R. If we substitute back that, we have power equal to V squared over R, which is equals to 240 squared divided by 100, and that gives 576 watts. We are also told to find current flowing in the circuit. So from P equal to VI stated earlier, current is equals to power divided by voltage, which is 576 watts divided by voltage, which is 240, and that is 2.4 amps. The third question is, Find the time taken for the heater to raise the temperature of 200 gram mass of water from 23 degrees centigrade to 95 degrees centigrade, taking specific heat capacity of water as 4,200 joules per kilogram per Kelvin. So these are problem that links mains electricity with the quantity of heat. So we have to remember that heat gained by water is equals to heat lost by the heater. Heat gained by water is mass of water times change in temperature. Heat gained is MC, change in temperature. Mass times the specific heat capacity times temperature change. And that is equals to heat loss, which is power times time. From this, it implies that time, which we want in this case, is mass times the specific heat capacity times change in temperature divided by the power, which is equals to 0.2 multiplied by 200 times 95 minus 23, which is the temperature change, divided by 576. That gives us 105 seconds. The last question, find the cost of using the heater for 2 hours a day for 30 days, taking the power and lighting company charges 5 shillings per kilowatt hour. So we have to start by finding the number of kilowatt hours. Which is equals to the power multiplied by the time, which is 2 hours, multiplied by the number of days, divided by 1000. In this case, when we substitute, we have 576 multiplied by 2 multiplied by 30 over 1000, which is 34.56. Therefore, the cost is 34.56 multiplied by 5, which is equals to 172.80. in shillings. So this is Kenya shillings 172.80. That's the end of the topic. Thanks for listening. Have a good day.